Hi everyone, welcome back to Chem Help ASAP. In this problem set video, we are going to be talking about the scientific method. We are going to look at a bar graph or column graph, and we will discuss independent and dependent variables. And we will also do some unit conversions, both one-step and two-step unit conversions. Let's go. Let's start with the scientific method set up as a flowchart. We move from an observation to a question. Once we have our question, it is very important that you do background research. Has this question been asked before? If so, what answers have other scientists come up with? Next, you move to your hypothesis. This is really your best guess. Once you have your hypothesis, you start to do experiments on your hypothesis. Once you have collected your data, you need to start to do some analysis on it. That will lead you to your conclusion. Now, the important thing about this flowchart is that conclusion can then lead you back to your hypothesis to reevaluate your hypothesis, or it can even take you back to your original question and modify your question. Now, often when we're learning the scientific method, students will ask, well, if your data analysis and your conclusion disprove your hypothesis, should that actually be published? And the answer is yes, of course it should be published, because you will have other scientists who may be asking the same question that you did, and instead of having them repeat the experiments and come to the same conclusion that no, this question or this hypothesis is incorrect, they can move on and ask maybe a better question or set up a better hypothesis to come up with a conclusion that actually supports a new hypothesis. Now, once you have enough experimentation and enough conclusions have been made, then you can go to a law or a theory. This is the law of gravitation. There have been enough experiments done at this point that we call that a law. However, not all laws are immutable. Einstein famously disproved Newton. So even if you have a law, a theory, or a model, that can always still go back to the question. Next, let's take a look at how to create a bar graph. Now, I chose to survey a number of people and ask them what their favorite kind of cookie was. My first step was to create a table that documented not only the kind of cookie they told me they liked best, but also keep track of the number of people that chose that cookie. When creating any kind of graph, you must collect your data first and then put it into graph form. Here is the bar graph that I formed. You can see I have given it a title, your favorite type of cookie. I have labeled both my x-axis and my y-axis. Now, how did I determine which should be on my x-axis and which should be on my y? This is where I need to determine what my independent variable is and what my dependent variable is. The type of cookie is completely independent of how many people like it. So that is my independent variable. The number of people that like a cookie is dependent on the type of cookie. That is my dependent variable that goes on my y-axis. When doing a bar graph, it's important to label each of your bars, and then the height obviously just corresponds to how many people like that kind of cookie. The nice thing about a bar graph is it makes it very easy to compare, in this case, the different types of cookies. At a glance, you can see that chocolate chip are definitely favored by more people than, say, oatmeal raisin, or that peanut butter cookies and ginger snap cookies are liked by the same number of people. Now let's do a little bit of math. We are given a table here. We're going to need to do 4 different conversions. Now, in order to do these conversions, it's very helpful to have some conversion factors handy. So over on the right-hand side here, I have placed a table with just common conversion factors when we're converting between SI and imperial units. We are going to complete this table row by row. So let's start with the very first row. We have 3.75 liters, and as the table specified, we want to convert that into gallons. So what we're looking for is a conversion factor that will let us move between liters and gallons. Let's go to our common conversion factors and see if we can find this one. Here it is right here. That is our conversion factor. Now, when setting up the math here, it's really, really important to make sure that the units you've started with, in this case liters, cancels. So here is my conversion factor. Liters goes in the denominator so that these units cancel out. The unit that remains is the one I want, gallons. Then I simply do the math in my calculator and I get 0.990 gallons. Let's go on to the second row. Starting with 15 ounces, and of course I want to convert to grams. So I'm looking for a conversion factor between ounces and grams. My table gives it right here. That's very handy. Again, just like the previous one, I want to be really careful that my ounces cancel and I'm left with grams in the numerator. So here's my conversion factor. I make sure I put ounces in the denominator so that I am left with grams. So in this case, I'm plugging it into my calculator and I'm going to get 429 grams. When students start learning conversions, they want to always put the 1 in the denominator, but it's not about what number is there, it's about what unit is there. So you can see between these two problems here, in one case, we had the number 1 in the denominator, and in the other case, we had it in the numerator. Let's go on to our third row. We're starting with 23.5 miles. We need to go to kilometers or kilometers. Find our conversion factor. Here it is right here. Again, we want to set this up so that miles cancel. So here's my conversion factor. Miles cancel. I'm left with kilometers, and I get 37.8 kilometers. Final row. We have 132 pounds and we need to convert it to kilograms. Again, I'm going to find my conversion factor in my table. Here it is right here. And I set it up so that my pounds cancels and I am left with kilograms. These were all pretty easy one-step conversions, but as we'll see later on, you can have multiple steps. Let's do a couple of these multi-step problems. Our first one reads, if you drive 3.7 miles to the grocery store, how many meters have you traveled? Again, I've put my common conversion factors here, and ideally I would like to find a conversion factor between miles and meters. You can see I've got meters to feet and meters to yard, but I do not have meters to miles. So I'm going to have to figure out how I'm going to get from miles to meters. Well, I do have the conversion factor between miles and kilometers. Now, once I get kilometers, then it is possible, of course, to convert from kilometers to meters. Then we just have a factor of 1,000. So that, I think, is going to be our easiest option. Let's start with our 3.75 miles. Now, remember, first we're going to kilometers. But just like we did in our previous problems, we're going to set this up so that our miles cancel. So now we have converted to kilometers. But of course, our question has asked us for meters, so we're not quite finished. Now we need to set up the conversion factor between kilometers and meters. This is where your prefixes come in really handy. We know that kilo is the prefix for 1,000. So there are 1,000 meters in a kilometer. Here is my other conversion factor. Again, notice that I make sure my kilometers divide out, and I am just left with meters. Now I simply plug this into my calculator, and I get 6,040 meters, or if you would like to convert it into scientific notation, 6.04 times 10 to the third meters. Either way is totally fine. Those numbers are the same. Let's look at one more problem. It reads, a Shire draft horse can weigh as much as 2,000 pounds. How many grams does a Shire horse weigh? All right, ideally we would like to move from pounds directly to grams. But if I check the chart that I have here, I can go between grams and ounces or kilograms and pounds. So I do not have one conversion factor to move between pounds and grams. So I'm going to have to put two together. So I am first going to convert my pounds to kilograms using this conversion factor. And then once I have kilograms, converting into grams is again just a matter of using the prefix. So let's start with our 2,000 pounds. Here's my first conversion factor. Again, I'm making sure that pounds cancel. This takes me to kilograms. Using my prefixes, I know kilo means 1,000, so there are 1,000 grams in 1 kilogram. Here is my second conversion factor, again, making sure that the kilogram cancels and I am left with grams. Now I'm ready to plug into my calculator. and I get 9.10 times 10 to the 5th grams. While it is very tempting to not write down units when doing conversions, I promise you will get more problems correct if you take the time to write down your units and make sure they cancel. Thanks so much for watching.